Hey, let's do volume again. Yesterday we did cylinders. There was a worksheet that I wanted you to try. The answers are on the last page. I said these are a challenge right here. I talked about the hexagonal prism. Now let's also talk about the pentagonal or pentagonal prism as well. How do you find the volume of those two figures? Okay, did you think about it? I did. It actually took me some thought. I didn't know it right away until I sat down and worked through it. And here's what we came up with. Right here, you're given this perpendicular height. And all we need to know is the area of the base. We'll put that area here. And we'll multiply it times the height of the prism. Now this prism is going that way from base to base. The other base will be back here. These are the rectangular faces that connect the bases together. All right. So the height is 8, right there. Oh, I put H, I'll put 8. Okay. So we just need the area of the base. So how do you find the area of a pentagon? Well, what we came up with is, I'll use a different color. Make a little triangle right here. And can you find the area of that triangle? You're given the height. This is regular, which means all sides are congruent. So there's a 4 right here, as there is on every side of that pentagon. And we know that the area of a triangle is 1/2 base times height. So it would be 1/2 times base times height. But that's just the area of one base. Or sorry, one triangle. So we have, let's see, 2, 3, 4, 5. We have 5 of these. So if we just take this and multiply it times 5, that's the area of the base, which is the pentagon. Multiply it times the height, you're done. Okay? So I'll let you do that calculation then. The hexagonal prism, or hexagonal, how are you going to do that one? Well, we need the same situation, the same formula. Area of the base times height. Now the 3 is the height. I know it might not look like it, just like it did over here, but it's connecting the bases together. Hexagon connected with hexagon by height of 3. So we'll put a 3 right there. So I had to find the area of that. Think about it. What I did is I broke it up into 2 trapezoids. Okay, you could do it that way. Or you could do the same approach that we did before. There's a triangle right there. And that triangle has a height of 3.5. I just kind of like drew over it. And it has a side length of 4. And how many of those triangles would there be? Well, it's a hexagon, so it's going to be 6. So don't overcomplicate it. Oh, that's way down there. Okay. Area of base is 1/2 base of the triangle, 4, times 3.5. Put these, I know it looks weird to put double parentheses like that, but you're multiplying that together. There's 6 of them, times 6, and then you take it times 3 at the end. And you have the volume of the figure. Okay. When I taught this in years past, a lot of kids would get confused when I talk about different kinds of bases. Like this triangle has a base and a height, and this prism has a base, which is an area, and a height. So those are different aspects of different figures. You just need to lock into which one you need. Okay, so within this, we had a base and a height. And then we have a base, which is the area of the base. This whole thing right here. In your notes, you might want to outline that. Same thing's true over here. Area of base. It's worth the time to write that down. Okay, and then we have the height. All right, so make your calculations on those. I think I took those straight from the worksheet, so if you multiply that out and look at the answer key, it should be the same number that you get from that. All right, let's move on. Today's lesson is supposed to be about cones. So what do you know about the volume of a cone? We've already laid this out in Monday's lesson when we wrote down your formulas, and that is that the volume of a cone is equal to 1/3 pi r squared times h. Okay? Oh, look. Area of base times height, and then I might not have written it like this. Maybe I put like divided by 3. That's okay. It's the same thing. It's a 1/3. Divided by 3 is the same as 1/3. I'm not going to explain that today. There's ways to explain it, but just know that it's exactly 1/3 of a cylinder with exactly the same base and height, and that would be the point right there. So if you were to inscribe this inside of a cylinder, with exactly the same circle for the base and the same height as the cone, this volume of the cone would be exactly 1/3 the cylinder. It's pretty neat how it works. It's cool. Okay, let's do a question based on something missing within our cone. So here's a cone over here. Go ahead and draw it on a piece of paper. And let's give it a height of 5 centimeters. And the radius is going to be unknown. You don't know what the radius is. But we'll know the capacity. We'll know the volume. We'll know how much water this thing's holding. Imagine this being like one of those little Dixie cups that you get water from, which you shouldn't use, by the way, because they're not good for the environment. But let's say it's one of those. And we know that it holds 131 centimeters cubed worth of liquid. Did you guys see my labeling error yesterday? I caught it in whatever you want to call it, editing mode, and I put a big cube on top of that, and I was just like yelling at you to label your answers. So it's still labeled, but let's do it with cube because volume is cubed and area is squared. I know this. I just make mistakes. You guys aren't here to catch me. Okay. Let's filter these in to the equation or to the formula for what we know. Volume, let's write it down one more time. I know it's right there, but let's write it down again. Times height. Volume goes in for V, substitute. 1/3 is a constant. Pi is a constant. We'll use 3.14 or pi button. We'll decide on that, okay? I'll decide in a minute. R is unknown. And we know the height to be 5 times 5 right there. So I guess it's a matter of what do you want to do first to solve for r squared, which is right here. Okay, we got to get that by itself. I think we could multiply by 3. That'd be a good way to start. See how that cancels the 1/3? And we take it over here. So 131 times 3, what is that, 393? Equals pi r squared times 5. This is all multiplication right here. You got multiply, multiply. Even r squared is r times r. So we could divide right now by pi and by 5. And you can do that in one step. That's okay. So divide by pi times 5. I haven't not done this ahead of time. So 393 divided by, I'm going to make a call. 3.14, and then divided by 5. Or take 5 times 3.14 and divide by that. I got 25.03, let's round to the nearest hundredth because I say so. Equals r squared. But we're not done yet. What's the opposite of r squared? Just like Pythagorean theorem, we do square root. So we need the square root of 25.03, which is, man, that's really close to 5. 5.00299. You know what? I think if we used a better approximation of pi instead of 3.14, it might have been exactly 5. But who knows? What did I forget to do? Label my answer. I'm not going to miss it this time. It's centimeters. It's a radius. It's just centimeters. That is the correct label. Okay, volume of cones. We have a formula. All we got to do is follow that formula. Plug in for what we know, solve for what we don't. Remember what I said yesterday? I called that plug and chug. That's my thing. Yeah. Oh, right. The thing with the guy. Yeah, I forgot about that. Okay, here's that thing. What are you doing? Oh, sorry. I didn't see you were playing a game over there. Can I play? Oh, you want to play? What does a sheep plus a wheat plus a wood plus a brick equal? I don't know what that equals. Sheep plus wheat plus wood plus brick equals a settlement. What? How was that? What? What game are you playing? I'm playing Settlers of Catan, and I had longest road.